Hi, I'm Abedi from 1000 Kelvin, and today I will demonstrate to you the capabilities of Amaize. I will do it through this customer design, which is a lightweight, optimized component which failed due to unsupported overhang regions that you can see with the red arrows on the left. This led to recorder crashes, and typically this would mean for the customer having to do compromises on the design, which lengthens the engineering time and the cost of non-recurrent engineering. The solution for this customer with Amaze was that they were able to print the job as with the design as it is, and in a few minutes analyze it and identify the most critical regions. But wait, there is more. Amaze generated an optimized print file, which was sent directly to the machine and printed correctly. And I will show you how this is done in a few moments. What impact did this have for our customer? They were able to greatly streamline the engineering process, achieving printability without support structures. So this may seem something complex to achieve, but let me show you actually how Amaze is simple to use, especially compared to finite element analysis. This is how you start using Amaze. No install, no license, just log in and use. And this is how Amaze looks like. We made it intuitive for engineers to use so that you can maximize productivities. Let's start discussing about the machines and look at the machines. We support several machines for machine formats. You can simply configure your machine part based on your machine. Amaze does not control your machine. You just configure Amaze for your machine, and Amaze generates a print file which is specific to your system. This ensures data safety, among other cybersecurity measures like encrypted storage and connection according to the AWS highest cybersecurity standards. And now let's look at how you can easily upload your print files in Amaze. You can drag and drop the file here, or you can upload it here. We support several formats, .openjz, .slm. No need to prepare the model or convert or mesh or anything when you have your files in this format. Just import and you'll be able to analyze your job. Also note that Amaze works on entire print jobs, not on single components. So you can analyze the effect that parts have on each other or on your print job. Once the print file is uploaded, you can proceed to the material selection. Amaze is already available for several materials. We currently support titanium 64, Inconel 718, 316L, but more materials are being added regularly. As we speak, in fact, aluminum is being deployed and copper is under development. If you have a special requirement in terms of materials, we can also work with your team to develop custom materials as the ones that you see here. For more info on this, get in touch with us. You can also select the machine along the ones that you have configured in the machine part, as you've seen earlier. After defining the material and the machine, you can select the issue you want to predict. Global overheating is one of the major issues for AM parts, but we have also developed a shrink line prediction, and we are developing and testing further corrections, like the one you see here, distortion, cracking, and surface roughness. Next, you can move to the process parameters. By default, every job starts with the prediction of the print issues that would occur if you print without corrections. And then you can see the corrections available. With Amaze, you as an engineer are in charge on the driver's seat, really. It is an AI copilot which helps you boost productivity. This means that you decide which parameters can be optimized and which shall not change by selecting the correction strategy that works best for you based on your qualification requirements. You can see the explanation for each of them by clicking on the info logo here. For example, the vector timing, which is adding some micro breaks between the individual print vectors only where needed. The vector order, which is reordering vectors in order to optimize the thermal history of the part, or the laser power and velocity, which is optimizing the process parameter window. And you can further define the parameters here. We can also develop custom correction strategies for you, as you can see here. And you can also run multiple correction strategies or correction scenarios, really, and later choose to print the one that gives you the best results. Finally, you get a recap of the choices you made, and you can submit the analysis and get notified via email or via text when it is completed, both the analysis and the correction. It is as simple as that. You as the user are in the driver's seat, and Amaze is your AI copilot. Now we will fast forward to the results and how to leverage them. So the first insight that you want to look at from Amaze is the 3D viewer, which shows you the big picture to start with. It gives you an instantaneous view of the critical areas and the impact of the correction. The 3D viewer can also be used as a guide for the user on adding support structures only where they are really needed based on the thermal history of the part. So in this example, as an AM engineer, you see that this downskin here is a critical area, and also the holes that you see here on top. You may choose to add support structures locally only there, or you can just go ahead and print the parts support free. And if you're wondering, yes, it is possible to print these parts without support, and we will show you. Sometimes there are other global indicators that can also be very useful for engineers. For example, you may want to see how the heat is developing, starting from the build plate and upwards, layer by layer. Therefore, we have added these two plots on the bottom left, the criticality risk and the macro scale temperature. These are showing you the criticality, which is the probability of failure at every layer, and also the macro scale temperature. And actually, you can see this peak, for example, here in the criticality, which is aligned to the downskin here that we have identified as a critical region. This gives you the opportunity to compare different correction strategies and choose the one that yields the better, the least criticality, or that minimizes the global temperature, as you can see here. It is also useful to notice that this is giving you an indication of which are the most critical layers that you may want to look at more detail into a 2D viewer. Let's now look at the level of detail and granularity of the results. Let's do it with a digital tomography. So we choose a layer, for example, the layer 2500. And for any layer, and we will look at this in particular, we can see the thermal signature and its impact on the printing process. So for example, we can look closer here, where we see a nice difference. So here, for example, you can see how critical is the region before the correction, which is on the left, and how much it improved after it. Now, can you imagine this granularity and this level of detail, for example, in a finite element analysis? You may also wonder, how do I see which vectors have been analyzed and optimized? And this is why we have introduced also the critical vector to the viewer. So again, let's look at an example here, and you can see the comparison in the uploaded file and in the correction, in the distortion reduction. So you can really see that on the left, there are several critical vectors, and you can see them at the resolution of the vector level. And you can see after the optimization how the results look on the right and how they have been massively reduced. By the way, do you remember when we introduced the shrink line prediction capabilities as well? Well, this is an example of how it looks. So for this part, Amaize identified and predicted a shrink line in this area, indicated by this red line here, which is where those arms are converging together. And this is in fact what the customer has observed in reality as well. So with Amaize, you can predict shrink lines that are, as you know, very dangerous fatigue stress initiators, crack initiators, and you can perform corrective actions based on your experience. If you want to inspect cavities, this is possible and simple with our cross-section capabilities, but most importantly for engineers is this button here. So you can download your print file for your preferred correction strategy. You choose the correction strategy that you want to export to the machine, and you will export a native file that you bring to the machine. If you're using EOS, for example, you get a task file, which you can send directly to the machine with your preferred workflow. If you're using Nikon SLM, you get a .slm file, which you can also print directly. And now a bonus content. Assume that you want to store or share a report of the correction being made with Amaize. You can do it by simply clicking here and generating your report. Let's look at it. So this report contains the information about the issues that you would encounter in your part if you print without correction, and then the optimizations for each optimization strategy that you have analyzed. You can store it for your use or share it. So let's wrap up together. For this part, we have seen how we are able to predict print issues without any physical print iteration or any time-consuming and costly finite element analysis. We were able to obtain an actionable corrected print file that you can take to the machine and print it directly. This is how Amaize enables engineers to reduce lead time, to increase yield and quality in AM. If you want to learn more, you can check our website, 1000kelvin.com, or contact us through the form below the video. Thank you for your time.